Hi, I'm Nick Brown. I'm an energy consultant here in California. And one of the interesting areas lately that I've seen on my project is all electric homes. It's now completely possible to remodel existing homes or build new ones with all electricity. And typically here in California, we use natural gas for four main areas of the house: heating, water heating, clothes drying, and cooking. The technologies have evolved to the point where it's completely realistic in terms of cost, in terms of cost of operations, and in terms of quality of life to switch all of those end uses to electricity. And there's a strong climate reason to do so. Recent studies have shown that all electric homes have about 50% the greenhouse gas emissions of a mixed fuel house. Now, you hear a lot about heat pumps for space conditioning, heat pumps for water heating. But one area you don't hear a whole lot about is electric clothes drying. So when my gas dryer went on the fritz, I thought, well, this is a good opportunity to dig into heat pump clothes dryers and find out what it would take to retrofit our existing gas dryer with an electric heat pump model. Here's the Miele heat pump dryer we selected. These use heat pump technology. So rather than heating up the air either through an electric resistance heating element for a standard electric dryer or through natural gas like we had before, the heat pump dryer uses compression cycle to create warm air that's blown through the drum and pulls the moist air out. Instead of blowing that moist air out through the air vent, it's then dehumidified through the compression cycle, like in your air conditioner. And that moisture is pumped out. Ideally, the moisture is pumped out through this line directly into your drain, like your washer would use. Alternatively, if you have a difficult application without access to an exterior wall, you can use this vessel here and just empty it after each load, and it'll catch the moisture. So these are roughly 3 times as efficient as the old electric resistance dryers. And they're supposed to be gentler on our clothes because they don't need quite so much heat. Here's our stacked washer dryer. Washer on the bottom, gas dryer on top. This complicates the retrofit a little bit, as most manufacturers will tell you that you can't stack a different manufacturer's dryer on top of their washer. But I found that they make universal stacking kits like this one, little feet that attach to the top of the washer to securely connect the dryer to it. That's from Miele. The other prep work you have to do is electrical. The Miele dryer that we selected is handy because it's 110 volt standard voltage in an American home and only requires a dedicated 15 amp circuit standard outlet. So I had to get an electrician out to run that extra circuit for a couple $100, but many of you may already have what you need installed in your house. Some other electric dryers may take 220 volt circuits, but that's not much of a problem either. We've removed the old gas dryer from the top of the washer, and we've got our universal stacking kit set up here, which we're going to secure to the top of the washer with some screws so that the feet of the new heat pump dryer fit squarely in these shoes. That'll hold it tight. We've got a little work to do back here in the enclosure. The new heat pump dryer won't require a gas line, and it won't require an air vent to the outside. So we're going to go ahead and seal up this old penetration that goes through the floor. In our case, it's about a 20-foot run to the outside. And it makes me think if we started out with a heat pump dryer, we probably could have saved a little money. We wouldn't have needed the gas line. We wouldn't have needed this air vent to the outside. And even though the heat pump dryers might cost a little bit more up front, probably on balance we would have saved a little money. Now the new dryer is going to drain here the same way the washer does. So the water it pulls out of our clothes will just get sent down through the drain. So I got a little patching up to do here, and then we'll install the new dryer. Here's the final product. The heat pump dryer stacked on top of the old washer. I did a load and I monitored the electrical draw, and it used about 0.7 kilowatt hours to do the load in the dryer. That's not bad. At 22 cents a kilowatt hour, that's 15 cents per load. For comparison, I checked the gas dryer. It used about 0.5 kilowatt hours of electricity plus the natural gas per load. So this is going to be at least equal in cost of operation to the gas dryer. Overall, we're happy with the new heat pump dryer. It's a pretty simple retrofit. It's economically sensible choice for new construction or retrofit. Operating costs are similar to our old gas dryer. And now we aren't burning any natural gas in our house, which has important health benefits in terms of indoor air quality. We also were able to close up the big hole in the floor here that was adding to our heating and cooling load. Here's why we're not burning any gas in the house anymore. Our induction cooktop's all electric, and so's the oven. The gas furnace is in the vented attic, and the tankless gas water heaters on the outside of the house. They're next on our list to replace, and then our house will be all electric. But removing natural gas combustion from the living space feels like a good move for our family's health.